welcome to the first ever STEM edition of Hack the Classroom. My name is Trish Malines DeZico, and I am your host for today. I started my career in the tech industry as a programmer way back in 1979, and while technology has changed a lot, one of the things that hasn't changed is the dearth of people of color in the industry. I left my career in 1996 to solve that problem by starting the Technology Access Foundation to ensure that students of color had the chance to build the kind of skills that they needed to participate in our STEM industries. And while the representation of people of color in the industry hasn't changed, the demographics of our country has. Did you know that 2014 is the first year students of color outnumbered white students in our public school system across the nation? Also, 60% of the children under the age of 5 are children of color. So this tells me we have a clear mandate to prepare traditionally marginalized students for STEM careers if we want to hold our status as the world's leading innovators. And at TAF, we partner with public school districts to help them transform their schools from the ground up. And we know that in order to reach every single student in a school, all the adults in that school must be on the same page. If the schools actually believe in their slogans that indicate every student matters, then every adult needs to be focused on creating an equitable learning environment. And it all starts with philosophy and culture. So basically, every adult needs to believe in the potential of every student and demonstrate that through their behaviors. And the pedagogy should be designed toward student voice, choice, and leadership. And staff at all levels, particularly in classrooms, should mirror the student demographics and have the wherewithal to bring their own lens to the work. And teachers should curate content that is culturally and communally relevant and challenges the hegemonic structures that we operate in. And finally, the school should work to develop an expanded community that bridges the gap between schools and community, supporting the reciprocity of learning and resources. Now, we must redefine the purpose of school as a hub for community development, recognizing that students don't live single-issue lives and need to live in thriving communities, where they see themselves in the curriculum and are treated as the future leaders they are. As a STEM-based organization, we at TAF see STEM literacy as a tool to ideate, to create, and to solve problems. Our goal is to produce students who are socially conscious and self-aware and armed with the 21st century skills needed to succeed, so they are positioned to create a world they envision personally, communally, nationally, and globally. And this week, you will have an opportunity to use the Hour of Code as a way to get to know your students better, to discover their genius, and to learn more about their backgrounds. For the first 2 days, you will be preparing for Hour of Code, with 2 days of lessons organized by grade level. And on day 3 is a digital career day with inspiring guest speakers from a variety of STEM fields. This will give you an opportunity to connect Hour of Code to real life. And this week is also an opportunity for you to reflect on and digest the importance of making coding relevant to all students. Even if it turns out they don't like coding, they will have the experience, and if it's relevant enough, they will find some other part of the process that they connect with. The great thing is you will get more insight into your students' interests and abilities. You get time to rethink how computer science is taught in your district, your school, and your classroom. You can reflect on why you're participating in Hour of Code or why you offer computer science curriculum in the first place. These are critical steps to creating an equitable environment in your CS classes. It's going to be a fun day for everybody, a fun time for everybody. It will serve an academic purpose, but more importantly, it's a way for you to level up your relationship building skills with your students and colleagues. Have fun, and I'll see you all at the end of the day. Thank you.
Hello everyone, I'm James Prothero. I'm Digital Learning Officer at Central South Consortium, and I'm an Assistant Head Teacher at Darren Park Primary School in Wales. I couldn't be more excited to be part of this year. I know you're all preparing for the Hour of Code, so I'm going to take you through a walkthrough of this year's Hour of Code resource. Welcome to the Hour of Code resource, A Tale of Two Villages. So when you launch into the world, you get this really neat book, which introduces the theme, A Tale of Two Villages. So the focus is the two contrasting villages, the villagers to the east and the fishing villagers to the west. And it really focuses on the differences between the two. And by bringing them together through coding, we can solve their problems. So it's a really interesting project, really interesting resource that focuses on diversity. So what we're going to do is we're going to work through these challenges within this Hour of Code. We're going to solve the problems, and we are going to help each village out. So I'm going to head over to the guide. So today the villagers and the villagers are still struggling in hard times. So we need to really help them to solve each other's problems and bring them together. Now, around the Hour of Code resource, you will see lots of non-player characters, and they're really easy to locate. They have the question mark on the top of them. And if I click on the NPC, it acts as a guide that will guide me through the resource. I can see as I go closer, this is the caretaker of the world. And this non-player character, this guide, will give me information and tell me what I need to do. And in this part, it's explaining that I'll need to use my agent to help solve the problems for each village. And it also asks me whether I want to use a block-based code or Python. Now, the age of the students that I work with is between 7 and 11, so we primarily use the block coding language. So I'm going to select that here. And we are now going to call agent by pressing C on the keyboard in Minecraft Education Edition. So we're going to call agent to help us to solve the problems and help each village out. So if I press C, see that my companion, my agent, has spawned into the world. So there it is. And the agent is a really cool companion within Minecraft Education Edition, and really visual. I know I work with primarily younger learners, and I find using the agent is really visual. You can program the agent, you code the agent to solve the problem for you. So we are going to be using block code to do this in this resource, but you can use Python as well. So if I click on the, so I'm going to press C, open my make code window. And for each of these challenges, to support me within the Hour of Code, I have the lines of code, the blocks of code that I am going to need to solve the problem. So the really cool thing about this is at the top you have your instruction. So I know that I've been introduced to my agent, and we need to move the agent onto the gold block within the world. So it's really, I have my toolbox on the left-hand side with my two lines of block code. So I know I need to use these lines to solve this problem. And if I want another hint, I have the light bulb at the top, and I can get some more help if I'm not really sure what to do. So with this first problem, I need to move agent to the gold block. So the first thing I need to do is drag the on start. And then I have this agent move forward by 1. So when I use this with my students, I really get them to focus on the problem. So we can see agent is here, and I need to move agent to the gold block. Now, I could see in the code that at the moment, it's only set to move forward by 1. So what I'd encourage my students to do really is to through trial and error, either to run that with one block to begin with, or to map out, to count out the number it needs to move forward. And what I find by getting learners to think about this and map that out, they're creating their own algorithms within Minecraft Education Edition and MakeCode, which they're then able to run to solve the problem. And I find this really a meaningful way of doing it because it's so visual, they can see what they're doing. So I've moved that, I changed that to 4, and I press play. Now I can see in my Minecraft world, so I can see that agent has moved and I am now ready to move on to the next step. So it seems that agent has a gift for you. So agent reached the gold block, and because of that, agent has a gift for me. So if I press C, so my prize for solving that first problem is a gift. And what will that gift be? So I can accept the gift by using these 2 lines of code. So on start, I drag the accept gift into the code, into the algorithm, and I press play. Now if I go back to Minecraft, I should see that my gift is in my inventory. So by running that code, I've been given a gift of a sapling, which I am now going to plant. If I plant that here, the caretaker appears again and tells me that it's time to move on and asks me if I want to continue using MakeCode blocks or to try out Python. So I'm going to go ahead and select continue and work with MakeCode blocks. And I'm ready to go. So it's my opportunity now to choose between which village do I want to visit, the illagers first or the villagers first, to help them solve their problems using agent and to bring the 2 villages together. Now I'm going to press close. Now the great thing about this is the caretaker within the game, I can call at any time. If I right click, it will appear and I can reset the code, I can pause, I can start again or quit. Now I'm going to go into the illagers world to begin with. So I'm going to follow the path. I can say hello to this person here, and I'm going to walk along. And I notice another NPC with a question mark. So I know this is my tasks, one of my challenges. So let's find out what we want it to do. And you can see the difference in appearance of the illagers to the first NPC that we clicked on, the caretaker. So I'm going to go ahead and click on the NPC. So I've clicked on the NPC, and this is a farmer. And this farmer needs some help because, remember, the illagers are really good at fishing, but they don't know how to plant. So we are going to use agent to help the illagers to plant. What we need to do is get our agent to till the soil, because when the soil is tilled, we will be able to plant. So if I press start activity, you can see that my agent has now appeared in the correct position. And I have this dirt here, this soil here that's untilled. And to be able to plant, to be able to farm here, we need to till it. So we will use our agent to solve this problem. Now, what we really need to think about now is how can we create an algorithm? How can we create a set of simple instructions to carry out this task? And if I press C to open up MakeCode, I can see the blocks of code that I'm going to need to use to solve this problem. to till the soil. So the villagers offer to help the illagers how to farm, but they need to prepare the land first. So we're going to help them by coding agent to till the first 2 rows. So we need to develop an algorithm. We need to develop a set of instructions to enable agent to do this. And you can see in my toolbox, I have till and move forward, and I have that variable of 1 time. Then I have agent move forward by a number, and then agent turn left and repeat. So there are lots of different choices, and the really cool thing about this is you will have learners that will think, okay, I'm going to do this in this way, where others will think, oh, I'm going to use a slightly different route, a slightly different algorithm to solve the problem. Now, one thing that I would do to begin with is I'd think, well, okay, how many blocks do I need to get agent to move forward? So, I might map that out. I might write that out, might make a note of that first. And I can use that then to help me with my algorithm. So if I can count forward, so I'm going to drag this and I'm going to say, okay, till and move forward one time. Well, it looks about 9 times to me. So I'll press that, and then what I'll do, because I feel trial and error is the way to go here, I'm going to run that code to see what agent does. So we can see that agent has tilled 9 blocks in front and is at the last block. So there's still this one left, and then we still need to do this row. So again, it's really interesting to think, well, what am I going to do? Am I going to start that code again, or am I going to add to that? But if I press right click on my mouse, I can call back my farmer, the farmer, and it lets me get a hint if I need a bit of help. I can reset the activity, or I can exit it and move on to something else. So if I reset the activity, I can then give it another go. So I knew that if I press C, I'll open my make code window. And I can see that 9 times looked about right, but what did agent need to do then? I can see I can use agent turn left. Now, do I want agent to turn left, or do I want agent to turn right? Well, I need to get agent to turn right, so it's facing in the correct position. And then move agent forward by 1. And then I can keep adding to this to create the algorithm. So if I think, okay, I'm now going to turn agent again, so it's facing in the correct direction. So I'm going to move agent right. And then I think, okay, how many times do I need to move agent to get back to till every block of soil? So if I add till and move forward, I think this time, well, I've moved agent forward 9 times and another 1 time here. So if I think on that logic, I'll type in 10. And remember here, I've got the light bulb flashing, so if I need a hint, it will give me one. But let's try this first to see what agent does. So I'll press play. There you can see agent has successfully solved the problem. We developed the algorithm together, the set of instructions, and we coded agent to till the soil. And the fruits of our labor are we've got an abundance of crops growing and enough food to feed the illagers. So I've solved that problem. Now I can use the caretaker to fast travel between different challenges in the Hour of Code activity, or I can walk around on my own. So I'm going to click fast travel, and it takes me to this menu where I can choose where do I want to go next. So do I want to go to the illagers town or the villagers town? So do I want to go to the villagers town? Do I want to go to the illagers town, the tree, or close. So if I choose the tree, I can see that I've completed one activity and I'm ready to move on to my next one. So if I walk towards my tree, you can see that the tree is growing. And by solving that first challenge, I've helped the tree to grow. So now I can continue wandering through the Hour of Code resource, solving the challenges and hopefully making the tree grow even bigger. Thanks for tuning in. I hope you found that helpful. Remember to check out the full lesson on the Minecraft Educator Center and challenge your learners to have so much fun during Hour of Code this year. I really can't wait to see how my learners interact with this resource. Great working with you. Bye.
Hello. I'm Iana Adegeye. I am a gameplay systems developer on Mojang and working on Minecraft. I'm originally from Detroit, Michigan, and now I live in Seattle. I started out not really knowing where I was going to go with my career. So ironically, it started with Minecraft. It was a game that I had played a lot since I was about 13 years old. And I enjoyed the creative aspect of it, where you can just like create things with blocks. And there was like a huge modding community. And so next I started getting into programming. And then pretty much after that, I decided I was going to be a programmer. My freshman year of college, I managed to land an internship at Microsoft, the Explore internships, which is centered around freshmen and sophomores who don't have as much experience in industry or like projects and working in teams and such. Microsoft had acquired Minecraft, like I think about a year or two before I started working at Microsoft. So I started messaging one of like the tech leads in Minecraft being like, hey, I hear you guys have an intern program for high schoolers. It'd be really cool if you take like a college intern. I finally begged just enough where they let me come over to do a trial by fire. And by the end of the summer, they told me yes, that they would give me a spot and we will be like the first cohort of like a college hire or college interns on like the Mojang team. So it was really exciting. I like wearing the swag, like when I go out. So like when I like go home and go to the airport and stuff like that, I like wearing certain Minecraft swag because the way kids react is really sweet. Like it's adorable. Seeing them get so passionate about a game. They're like, oh, I recognize that. And that's really sweet. Programming in itself, I find is entertaining because of like the technical problems and how you have to kind of walk yourself through a design and say, okay, this is where I want to end up and this is where I am. How can I get to that, like that final step? I guess also just the people on my team, they're so like energetic and eclectic and I love it. And like they're very passionate about what we work on and even other games in their free time. And I think that makes me like really happy with working with them. Like they make work an enjoyable experience. The way I think of programming almost is like the way an artist may think of their tools. You have several languages to choose from. So like this is like choosing your different medium when you're going to work in art. Within those like individual languages, there's so many different libraries you can choose from. Like what are you trying to build? There's multiple different ways you can build it and there's multiple different like resources you can access from to do so. So it's like, okay, we have different colors and paints and all kinds of different things you can use to try to get to this final picture. And there's the logical side of it as well of like, okay, do I want this to be efficient? Do I want it to be scalable? Do I want it to be sustainable? Like, are we going to redo it later? How easy do we want it to be? Who else is going to come look at this code? So how like technical or not technical does it need to be? One really cool part that kind of mashes the tech and the art together is our artists who work on Minecraft. We create tools for them to use to make all kinds of cool features in the game, like the skins for the mobs and like the block models so they look nice and stuff. With any technical thing, you need some sort of visual. So there has to be some creative aspect in there to make sure it's presented, especially any user-facing software. It needs to be presented in a way that makes sense. I will say that the number of people I know who have self-taught themselves like some kind of programming language is just like it's a lot. There's a lot of people who do that. There's a lot of resources online. And kids are very, very smart. They'll surprise you with how smart and how easy they can pick up certain things. So for teachers kind of, I guess, worried about introducing coding into like the classroom, we're getting to a point where it's accessible even for people who don't really understand how to code. They can understand this is what point A to point B is, and here's the tools the kids can use, and the kids can just kind of figure out, all right, this is how I put these blocks together to get what I want. For me, like as a young child, I did lots of like Legos, Lincoln Logs, train sets, puzzles, all of the sort. So for me, it really enriched that like logical side of my brain, like just problem solving in general. So even if you don't like make a career out of programming, that's totally fine. Like you can do it as deep or as shallow as you'd like it to be. I mean, tech's not going anywhere, right? So even if you don't make a career path out of something, it's still fun to tinker or like even to understand how certain things work. Having even like the slightest idea of what's going on will always help you. Okay, so that was my time. I'm Ayana, again, game play systems developer on the Minecraft team. And what I have to say to all of you is just explore your passions. Never give up. Try again. Even when you feel confused, keep going. Because when I was learning how to program Java, it was really, really hard because I didn't have anyone like there physically teaching me. But now here I am in like a programming position. So you never know where life can really take you. Just go with the flow. Go what feels right for you. And bye.
I'm Michelle Zimmerman from Renton Prep in the United States, and I'm here with two of my students. Do you want to introduce yourselves?
Hi, I'm Alexandra. And I'm Gabriella.
And we'd like to talk to you about some of the things that have been transpiring over this school year. For the past 10 years, I've been working with technology in education and trying various different concepts that we've really wanted to push the boundaries. And this year for us, it's been HyFlex model. One of those HyFlex experiences gave students who are fully remote, like Alexandra and Gabriella, a chance to see some of the supplies and resources that they wouldn't be able to have at home. And so I have them here as experts because even though I can do research and investigations and observe things that are happening in the classroom, the best experts to talk about the experience of engagement are the students themselves. They're the ones who are right in the middle of the action. So, can you tell me a little bit of what it felt like to be part of a HyFlex experiment with a Light Lab?
It was a little bit hard at first, getting to know everything and all the apps and how it worked, but I think now I'm getting used to it. There are many new updates and new apps we were using. Confusion.
And this is the first year that you've had a math teacher who's fully remote and you're fully remote and learning something with coding and technology and math all mixed together.
It's easier in class because you can just tell the person that like right there. But a lot of times when you're remote and you have a question in class, you can just tell the person right away and fix what you need to do.
Those are great examples and highlight some of the challenges it feels for a teacher, because when everyone's in person, you can walk around the room, you can see who needs other support, and if someone's behind a screen or if a computer dies, or if the teacher is working with a group of students in person or on a remote call, it's hard to see everyone at once. Like when we did the bubble photography, and then we had real life experience of a professional photography setup in there. And if you couldn't see something, or if you had a connection with the documentary we watched on the science of bubbles, what inspires you to come off of mute and ask a question?
What inspired me was that, like, I've never seen that before. So once I see it, I have so many questions to ask that I can just come off mute, say it, and they're right there to listen to it because it's live. Yeah, usually when I see like unexpected things, like for example, the bubble photography, I used to always think of bubbles differently. I was always like, oh, it's just maybe a soapy ball flying in the air. But when my sister was blowing the bubble, and a few times it landed on the floor, and we were like, whoa, it's changing color. And then it showed like a sunset and then the galaxy and then all these other color schemes. We gotta ask questions how this works and why.
And then our team's call when we were recording in HyFlex, Alexandra, you made some great connections with that science documentary and said you saw the swirls that looked similar to Jupiter and planets, and how people were using bubbles to help them understand math and science when they couldn't actually travel to those planets.
The bubbles looked like Jupiter's storm. So the surface, I remembered it because I was like, that is so weird when you think of this least expected object to be, I don't know, discovering what storm is going to come next in Jupiter.
And for teachers, we want to figure out ways to capture your learning in that moment before a bubble burst or before the colors swirl to something different. And one of those ways is by creating little documentaries or process journals or ways to document your learning. Any of those examples that you want to talk about?
Whenever, like, when we were doing the carving pumpkins project, and once we were painting pumpkins, my brother, when we were doing it, he got inspired and said, "Oh my God, Mama, you have to buy me a pumpkin so that I can do that too." Yeah, he would walk around with a paintbrush. He's like, "Do you need help with anything? Do you need help?" And we're like, "Yeah, sure, paint here, paint there," and then he'd get distracted for 10 minutes.
You just gave a perfect example of how learning happens in the presence of other humans. As part of us being a Microsoft Showcase school, we're wanting to continually transform and be part of that transformation framework. And part of that is social emotional learning and unexpected learning environments and situations, different ways that we can use technology. Is there any other example that you wanted to share that worked well for you to help you stay engaged?
The hologram project. All you need is a special container and a special video, and all you do is put the container on top of a smartphone or a tablet. When you make an example of how it would look, then you say to yourself, "Wow, that's so cool. I'm gonna try myself and make it myself." And then even when the project is over, you still have that strategy in your head, in your mind. So then later on, you can still try and do it. Yeah.
Was there another project that you wanted to share or another example that you had?
The project called Camera Obscura.
Yes.
It was a project where the Camera Obscura, I think, was the first camera. There's a pinhole, and then when you put your eye to it, you see what's out there, but instead it's like upside down. So we got to learn how it worked and made a documentation in this way, and we also got to make it. One of the things I like about all the projects we're getting assigned to is that they're so easy. You can make them at home. You could just gather maybe some boxes or something to make that right setting for the bubble photography.
I think those are really great ideas, and I like how you're mentioning different things that were in OneNote, because all those criteria pages and the remote learning becomes part of a OneNote collection, and that you have a space to be able to collaborate and check off boxes to make sure you've met that criteria. And then you've used Sway, you've used Minecraft, you've used PowerPoint to be able to share those ideas and concepts with people. What is your favorite tool to use when you're working remotely?
OneNote and Sway. OneNote because there I can just make myself a schedule, and Sway because I can just make an easy presentation, add things from my file. It's just so easy because PowerPoint is a little more complicated, although I like the special effects they have. But Sway could be at least a 20-minute process for basics to put everything in, which is super easy and fun because you could pick any format you want, and there's old style and modern and different templates. I like Teams because I just have everything on the side, so it just tells me chat, calls, history, and calendar and assignments.
Yeah. So do you have anything else that you wanted to say that you wish teachers would know, or that you wish other adults would know what it's like to be a student?
One thing is sometimes there are many calls that overlap each other, so I don't get as focused because I get distracted. For example, with Mr. Morris, I'm like, whoa, that's so cool, and then for the past hour, I'm still thinking about it. About that camera, about that bubble. I'm like,
so that part's good news, that it gets you thinking about something that you're learning, but frustrating if you're so excited about it that it's hard to change your mind to another topic.
One thing that I wish was that we had more time, because just like she said, the calls are overlapping a lot of times, and I'm like, which one do I go to?
And I wanted to give you another compliment. You're doing a great job staying engaged through some really challenging things. You're helping us blaze new trails and set new ideas for high-flex learning and helping us understand what it's like from that side of the learning situation.
Thank you.
Thank you.
Thank you both so much. You gave some great ideas, insights, and some things that are helpful for me, but also for a lot of educators who want to know your perspective.
You're welcome. This counts for extra credit, right?
Well, the best thing about this is the learning experience you had for doing this.
Bye. Bye.
Hello everyone, my name is Jacqueline and I'm from the Microsoft MakeCode team, and I'm here with Cyan and Sage. And we're here to show you some really fun coding activities that you can do with your kids or your students for Computer Science Education Week this year. And we're going to be using a tool called MakeCode Arcade. Whoop, whoop. Can you guys tell me what is MakeCode Arcade?
MakeCode Arcade is a super duper 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 fun website
Okay.
that teaches kids how to code
Yeah, and what do you make with MakeCode Arcade?
video games.
That's right. So you can code your very own arcade retro style video games, and then you can also share them with friends and download them onto little handheld game devices.
Called Meowbits.
That's right. Where's your Meowbit? But they look like this. So you can plug these devices into your computer, download the games that you've coded, and then away you go. You can just play on these devices. So let's go ahead and get started. We've compiled a list of some fun activities to do for Hour of Code this year, and you can find them all at aka.ms/arcadehoc. So are we ready to dive in? We ready to do some coding?
Yeah.
Yeah?
Coding.
Okay, so let's go ahead and get started. So I'm gonna go ahead and go to aka.ms/arcadehoc, and this will take us to the Hour of Code page. And on this page, you can see we've got 3 cool activities you can do. They are
Play
design,
and code.
That's right. So for the first one, this gameplay activity is a game called Asphodel Follows Directions. So Sage, can you help us out here and tell us a little bit about what this game is?
Sure.
So what does it do? Who's Asphodel?
Well, Asphodel is a witch that you can see.
And you have to help her navigate through a maze, right?
Yeah. And there are some directions to help her to the trophy. You have to press A or the space bar on your
Keyboard.
to make your cursor pick up the arrow. And to move it, you press the buttons up, down, left, and right. And you also press the space bar or A to put it down too. For B, or the Enter key, that makes Asphodel move. Like Mom just.
Like I just pressed button B and she's just going straight up. That doesn't look right, right?
Yeah. So you have to move the arrow.
Okay, so I'm pressing button A or the space bar to pick up and drop off the arrows. So then she hits the arrow and then she gets to her trophy.
Yeah.
Great. Okay, and now there's multiple levels, right?
Yeah.
So, and they get a little bit harder.
So we don't have time for all of them, but we can show you the first two.
Yeah, so was that right? No, that wasn't right.
No, since you have to put it there.
Right in front. Okay,
and then,
so then what happens? And then
you
dear.
still have to do
gotta
the other arrow.
Move this arrow and put it like right here, you think? Okay, so then she hits both arrows and gets to the trophy. Hooray!
And
you can see the mazes start to get a little bit more challenging, right? So she has to move to the right, she has to move down, and then we have to get arrows that move her to the left over here.
Notice how you can go like outside of the.
Yeah, makes it easier, right? So you can
Yeah.
move the cursor outside of the maze, but Asphodel can't go outside. So then she goes up, she goes right, she goes down, she goes to the left, and then she goes up and makes it to the trophy. Hooray!
Asphodel.
All right, now the levels do get increasingly more difficult. There's keys and gates and all sorts of things
Yeah,
here.
and paint, which
And-
she can like dye her hat,
She can dye her hat
and
to
that
get through the
allows
gate.
her to get through a red hat gate or a blue hat gate.
Now, the second activity is this design game, right? And so this, you can actually draw your own game characters.
And I wasn't playing.
Okay.
No way.
So this is a tutorial. You start off with an existing game, and then you basically just customize it, right? So this background image, Cyan, can you tell us what this artwork is?
Party in space.
Okay, so your game takes place in outer space
Yeah.
where they're having a party.
Yeah.
Okay. And what are all these like colored things are?
Confetti.
It's confetti. Okay, I see. And then your sprite, this little sprite guy, what is this?
It's it's a purple space worm.
It's a purple space worm. All right, so the next step, we need to change this projectile from a clover to something else. So we're gonna erase this clover here that was here before.
Clover be gone.
Clover be gone. And then, Cyan, what are you gonna draw or design here that will be something that your space worm wants
Are
to
there
eat?
spaceships? Oh, I know what I'm gonna do. Okay, guys. So the white is going to be. It'll show out because there's
Because it's in outer space.
no other white.
Yep. Okay.
All right. Worm will be the one. That's good.
All right. So now in our game here, if we do full screen, we've got our little worm, and she or he is going to go collect these little cool dance moves to earn points. So there's more things you can do in this tutorial to design your very own arcade game. And the last activity is a coding tutorial. So let's go ahead and look at the Shark Attack code tutorial.
Shark attack.
So in this tutorial, it actually gives you step-by-step instructions for what to do. So Shark Attack is an underwater game. So we're gonna go ahead and set the background color, and you think we should do it blue color?
Yes,
more
we
like
went over this 1,000 times.
Teal.
Teal color, okay. And we need to find a sprite.
That would be
and
kind of
so
like a metallic color.
we're gonna add a sprite block to our code.
And we're gonna go to gallery
We're gonna go to
since we
gallery.
don't have the time to actually hand make this.
Draw it, yep.
Yeah.
And we've decided we're going to do a Nemo fish.
We're gonna do a clownfish, what do you think?
Well, maybe angelfish.
Angelfish this time? What do
Yeah.
you think? Yeah, okay.
Angelfish.
Angelfish as our sprite.
And then we're gonna
And,
have the.
And then what next?
We're going to have the fish move when we press the buttons.
That's right. Move my sprite with
I
buttons.
have the fish.
So
I need to
now
move it to
the
there.
fish can move, but we also have to make a boundary, right? Since
Yeah, because look, the fish can move
yeah.
straight off the screen. So we need to set a property on this sprite
Yeah.
that says fish, you need to stay in
Yeah.
the aquarium.
and sooner or later there's gonna be a shark attacking this fish.
That's
And this fish has to
right.
move like up and down and avoid
Yeah,
the shark.
avoid the shark. It's gonna be crazy.
Yeah.
So, but unfortunately, we don't have time to go through the entire
Yes.
tutorial, but highly encourage you to. All right, now for educators and teachers out there, there is a page for educators.
I didn't know that.
Yep, that has more information about learning outcomes for all of these activities and
Look,
the-
envelope. I think.
Those are gates.
Oh,
yeah,
those are-
those are
oh.
switches. So if you're
What's the
interested
pink
in
thingy,
understanding what the computer science concepts that the kids will be learning are, come to this page.
What?
There's also some tips for facilitation, as well as additional resources for educators. If kids get done early with these 3 activities, there are additional...
Which they probably will, because kids are awesome. There's Wonder Woman maze, NFL football, Chase a Pizza, Lemon Leak, Galga, and Catch the Clovers.
That's right. And then also more links to explore more about MakeCode here. All right.
Because arcade is awesome and MakeCode is awesome.
So once you're done with all of your Hour of Code activities, you can also print out a certificate for Hour of Code.
We have our own.
So you guys want to show off the certificates that you got. That's right. So you guys each earned these Hour of Code certificates for going through all of the activities. Congratulations. So thanks so much for joining us, walking through these MakeCode Arcade Hour of Code. And you guys want to say anything else?
Bye. Yeah, bye.
All right. Well, happy coding and best of luck.
MakeCode is awesome.
All right. Bye.
Bye.
Hi, Kiki here, and today I want to walk you through one of my unplugged activities from my book, How to Be a Coder. If you're not familiar with unplugged activities, then let me just give you a heads up about what they are. Unplugged activity is an activity that you can do, usually a computer science activity, but they exist for everything, where you do not need anything that's plugged in. So you don't need a computer or the internet or anything of that nature. So today, the activity I'm going to be walking you through is a computer science activity on variables, but you're not going to need a computer to do it. Let me show you what I mean. We are going to open up to page 48, and we are going to do this variable paper chain. Now, as you can see, there is a program right over here, and this program is the unplugged version of how you might create a paper chain. But in this case, we want each link in the chain to be a random size. We're going to get the length of each strip of paper, so the size of the loop, by rolling a die, and that will give us more or less random length. Now, if we had to wait until we knew all the lengths to be able to write the program, then it would take us a long time. The program would be really long, and it would only be good for one kind of chain. It wouldn't be kind of forever random. And Tosh's program would look just like Sam's. So we don't want that. We want Tasha's and Sam's programs to both be unique, but we want to write one program that will work for both of them. We do that using variables. A variable is kind of like a placeholder for information in your program. So if we don't know what the number is going to be for the length of our chain, we only know that it's dependent on a die roll to figure it out. We can put the variable die roll right in our program and say whatever you roll on the die for this section of the program, that's the length that your chain will be. Now you can write your entire program. To start the program, you're going to want to roll your die, and whatever length you come up with, you're going to take that, add 5 inches, and cut your strip of paper. Then you take your link and you tape it. Now you have your first link and you're ready to add more. For the rest of the program, you can do a loop, and the stuff inside that loop you're going to do multiple times. In this case, 15. And what we want to do is roll the die, and whatever number we get from that, we'll add 5 inches, and we'll cut our strip to that, and then we'll thread it through our original. And there you go. Using a program like that with variables, everyone can have a unique paper chain with their own random size links. Happy coding.
Hi, my name is Mary Hoffmeister, and I'm an instructional technology specialist for the Cherokee County School District, just north of Atlanta, Georgia, in the United States. Did you know that you can teach computer science without a computer? At its core, coding is about problem solving and critical thinking, and there are lots of fun ways to engage those skills while learning offline. This unplugged activity allows students to work on coding concepts like algorithms, sequencing, and loops without a device or an internet connection. It's perfect for beginners at any level. I've used it with elementary and high school students alike. And since all you need is something to write with and paper, it's easy to do in the classroom, and it's also really great for our students to do that are learning at home. It's also a great solution for classrooms that have to share devices. Half of your students could work on the accompanying Minecraft lesson, while the other students complete the offline activity. Then they can swap off, and they both get a turn to do the entire lesson. Computer science is unique because it brings opportunities for both collaboration and self-reflection. It's amazing to see students who are more introverted thrive while they're processing things on their own, and then turn that around and get the opportunity to work with classmates and be a part of a group, collaboratively solving a problem. What I love the most about unplugged activities, though, is seeing how they can really spark students' interests in STEM learning. Once they start exploring these different coding concepts, you can use lessons like this to help them find a programming language that best fits the way they think, opening avenues for them as they pursue their future careers. So the final result of this first activity is that the students are going to create an image using the code that they are given. The starter code that they are given is organized in a way to help the students stay organized as they go through the process, and also mirror kind of the coding languages that they may encounter as they work through different types of activities. One thing that we noticed that helps students to stay organized is that we tabbed over for each row in the code. So if you notice on the sample code, it is tabbed over when they change rows. What that allowed was for a student that got lost, they could go back to the row where they stopped and figure out where they were without having to start their picture over. It helped with some of that frustration, and it also helped for them to troubleshoot issues if their picture didn't quite come out the way that the sample picture should have. After the students create the picture that they all match because they're using the same code, then students are given an opportunity to make their own. So they draw their own pixel art creation on a blank grid, and then they write the code to accompany that picture. And by accompanying that picture with the code, they can then give that to a classmate, a friend, a parent, or even a grandparent, and have them try and complete the series using code that the student has written. That's it from me. Thanks for watching, and stay tuned for more Hour of Code Prep. Bye.
Hi everyone, I'm Susie from the Minecraft team, here to show you where to find the Hour of Code resources we talked about today. Everything you'll need is at aka.ms/HTC2020. Don't worry, we'll drop the link in the chat now as well. Every resource you're about to see is free and available to all educators and parents interested in Hour of Code. Let's dive in together. If you have any questions, feel free to post them in the chat or post them on Twitter by tagging @MicrosoftEDU or #HackTheClassroom. So let's take a look at this Hack the Classroom STEM Edition page. You'll find all of the Minecraft Education Edition resources you need right here. The first one is the Minecraft Hour of Code 2020. This uses basic coding concepts to bring two villages together in the free Hour of Code lesson. Students will learn about cooperation and inclusion and practice social emotional skills. The next resource is the Computer Science Subject Kit. If you're looking to go beyond the Hour of Code, Minecraft Education Edition has over 150 hours of free coding and computer science curriculum for you to leverage for beginner or intermediate coders. The next is the Coding Academy. This is a brand new 8-course learning path that teaches any educator that wants to use coding in Minecraft how to get started and how to use that entire 150 hours of curriculum. And the final resource is the Hour of Code Facilitator training. This course on the MEC walks through everything you need to know to get started with facilitating the Minecraft Hour of Code this year. Now let's dive a little bit deeper into the Minecraft Hour of Code resources. I'm going to click on Start Coding, and we're going to be brought to the landing page for the Minecraft Hour of Code. There are so many resources on this page. You can watch the overview video, download Minecraft if you haven't already. Remember, this lesson is available no matter if you have an Office 365 education account or a Minecraft education license. You can check out the lesson plan, which has a ton of great resources, including an educator guide, which walks through all of the themes of the lessons, all of the answer keys to the exercises, and even has a walkthrough video that introduces you to the lesson and the activities itself. The next is the Hour of Code Facilitator training on the MEC. And lastly is the more computer science resources. So let's click here and see what this 150 hours of coding curriculum looks like. This is the computer science landing page on the Minecraft education website. If we scroll down, we'll see an outline of how that 150 hours of content is broken up into beginner, intermediate, and advanced coding curriculum. If we scroll down, we'll start to see some of these resources. The first part is the Hour of Code from 2019, this year's 2020 Hour of Code, and a few other coding lessons. Next, we get into some of the curriculum. This is Coding Fundamentals. It's 18 hours of curriculum broken up into 3 sections, which is really great for coders that are around 8, 9, and 10 years old. My favorite lesson is the Sea Turtle Assistant lesson, where you actually use your agent, which is our little coding robot buddy, to clean up all of the trash on the beach. And when we have successfully completed the activity, we get to see baby sea turtles hatch and go into the ocean. Pretty great stuff. When you continue to scroll down the page, we get more and more advanced into that more intermediate coding curriculum. Eventually, we'll see that there are tutorials where you can actually focus on one coding concept if you need a little bit more practice. And then we'll get into some of our Python curriculum for our more intermediate coders. Now let's go back to the Hack the Classroom STEM page and see what else is there. You can find some great MakeCode Arcade Hour of Code activities on this page. There are 3 play, design, and code activities your students can do for free online and then print out the Hour of Code completion certificates. There are also some additional resources for educators and parents, including links to full MakeCode Arcade curriculum, some online learning resources, and how you can get handheld gaming devices for arcade. Thank you so much for joining. Remember, you can find all of the Hour of Code 2020 resources for both Minecraft education and MakeCode at aka.ms/HTC2020. Happy coding!
Hey, thank you so much for helping kick off this year's Hack the Classroom event. I hope you had a blast and are geared up for days 2 and 3. So tomorrow, there's more Hour of Code Prep where we will level up from block to text-based coding. And day 3, we'll have a digital career day with special guests from different STEM fields. So kick back and relax for the rest of the day. We'll see you bright and early tomorrow at 9 a.m. Pacific Standard Time. Thank you.